Fractions are one of the first big math challenges that we encounter as we learn mathematics, and they can leave us scarred for years if we struggle with the rules. But that difficulty can be overcome, no matter how many years have passed. The truth is that you probably learned the fraction rules in a confusing, ineffective way. Your teachers asked you to memorize too much too quickly. I hope that I can unclutter the fractions rules in your mind. The ultimate goal is to not see fractions as these separate numbers with their own special rules, but as part of the normal system of numbers whose rules you already know very well. So if you can, try to clear your mind of fractions. Forget what you think you know. Let's start over with a clean slate. Let's start with the most essential idea. Fractions are just division problems that we're too lazy to solve. There's a reason that we very rarely use this symbol in high school. It's easier and better to represent division with a fraction. Sometimes we're able to complete the division and make the fraction disappear quickly and completely. Other times, we could easily change our fraction into a decimal, and there are definitely cases where that's the right move. We often have these conversions memorized, but a calculator would do the work for us if we simply entered the fraction as division. But sometimes the decimal is not helpful. 9 divided by 7 creates a gigantic mess. If we don't have a calculator, the division would take a long time, and even if we did have a calculator, the resulting decimal is super annoying. But that's why fractions exist. 9/7 is much easier to work with. Fractions give us permission to be lazy. They let us skip the division that we don't want to do, and they prevent us from having to work with decimals that will make the arithmetic harder later on in the problem. Right now, you probably hate fractions because you think that they make math harder. Flip that idea around. Fractions make math easier. We like fractions because they let us be lazy. Now there is still one important place with fractions where we're not allowed to be lazy. We need to always fully reduce fractions into their simplest form. For most tests in school and on most standardized tests, 12/8 will not be an acceptable answer. But if you think of fractions as division, then reducing is really like, we need to do as much division as we can, but we're allowed to leave the leftovers. If you are confident with the times tables, then it's relatively easy to break numbers down into their factors. 12 becomes 4 and 3, and 8 becomes 4 and 2. Reducing a fraction is really just asking how many of these parts can we divide. When we cross out numbers that appear on both the top and the bottom, it's because they divide to 1. 4 divided by 4 is 1, and 1 in multiplication and division basically disappears. But since 2 doesn't evenly divide into 3, we don't have to do that division. We can leave the leftover numbers as a fraction. Now, you won't always be able to reduce completely in one step because you might break numbers up in different ways. If we make 12 into 6 and 2, then we can still reduce, but we would not have reduced completely and would still get the answer wrong. This is a big problem for some people because they know that they need to reduce fractions, but they treat it like a step in a process and not as a final goal. They reduce a little bit, check the step off their list, and move on without really thinking about the purpose of reducing. My advice is to change the way that you think about reducing. Instead of worrying about breaking numbers apart into the most efficient factors, you can use factor trees to make sure that you are always breaking a number down completely. Once the ends of all the branches are prime numbers, you can start to match numbers on the top and the bottom. The leftovers are the fully reduced fraction. Just stay organized. In elementary school, you spend a lot of time converting improper fractions, like 3/2, into mixed numbers, like 1.5. It becomes a habit, and you keep doing it in high school. But algebra and higher level math classes never use mixed numbers. They're just not convenient. I am going to give you permission to take everything you know about mixed numbers and file it away in the deepest corner of your memory. Occasionally, you might need to dust off this knowledge, but for the vast majority of math questions, 3/2 is much better than 1.5. Improper fractions are good, and mixed numbers are bad. From now on, keep your answers as improper fractions. For some weird reason, the first thing that we learn to do with fractions is add and subtract them. But that's literally the hardest thing you can do with fractions. The easiest thing is multiplication. Simply multiply across the tops and across the bottoms. It shouldn't be surprising that this is so easy because multiplication and division go really well together. In fact, they're kind of the same thing. And because of that, we can actually reduce fractions as we multiply them. Reducing first is easier because big numbers are hard to break apart, and without a calculator, smaller numbers are easier to multiply. At first, this question may look like it's going to be a huge pain, but if we break these numbers apart, we can make the multiplication much easier. This is yet another reason why fractions are actually helpful. Well, if fractions are already division, then it shouldn't be that hard to do a little extra division. In fact, division of fractions is really a slightly twisted version of multiplication. Just remember to keep, change, flip. Keep the first fraction as it is, change the division to multiplication, and flip the bottom fraction upside down. Now we have multiplication, and it's no different than what we talked about before. You can reduce first to make things easier. The worst thing about dividing two fractions is that they start out looking scary. Don't let that intimidate you. Keep, change, flip, and you're back to something very easy. Finally, we get to addition and subtraction. Like I said before, we tend to think of addition as the simplest thing that you can do with two numbers. But with fractions, addition is a nightmare. The reason is that we're usually asked to add two different kinds of things. It's kind of like in algebra when we have x squared plus x. They look very similar. It feels like we should be able to combine them in a simple way, but we know that they're not like terms. An x squared and an x are two different kinds of things, and so they must be kept separate. Fractions are similar. 11/15 and 1/6 are two different kinds of things. They're not like terms. However, with fractions, we do have a way of converting them so that they become like terms. Getting a common denominator is our way of getting these fractions into a format that allows us to combine them. The smallest number that is evenly divisible by both 15 and 6 is 30. Both the top and the bottom get multiplied by the missing factor so that each denominator gets to 30. And I want to be very clear about what we're doing here. Remember that 2 divided by 2 is equivalent to 1. So what we're actually doing here is multiplying each of these fractions by 1, which we know doesn't really do anything to the numbers at all. We're changing how these fractions look without changing their values. Now that we have common denominators, we can add or subtract the tops and keep the bottoms the same. Remember, though, that we still need to reduce our answer if we're able. And unlike multiplication, we cannot reduce addition or subtraction until the very end. That's because when we're getting common denominators, we're essentially unreducing each of these fractions by using the special properties of the number 1. This is one of the reasons why adding and subtracting fractions is so annoying. The first step involves making the fractions bigger, which runs counter to every other impulse we have with fractions. In my opinion, the main reason that people struggle with the fraction rules is that they learn how to cross-multiply, which is the first way that we see fractions mixed with algebra. It comes up a lot when we work with ratios and proportions. The problem is that we end up doing multiplication with fractions in a way that completely undermines the real way to do multiplication with fractions. It's no wonder people can't remember these rules. They're being taught two completely opposite things. Here's the solution. Forget about cross-multiplying. Get it out of your brain. You can get by without it. Instead, remember that fractions are division, and in algebra, when we want to get rid of division, we do the opposite, which is multiplication. So if I wanted to get x by itself, I would need to get rid of the 3. I can cancel it out by multiplying both sides of the equation by 3. On the right, 3 divided by 3 is 1, so we're left with just an x. And on the left, we have a simple fraction multiplication problem. We multiply across the tops and across the bottoms, the normal way to multiply fractions. If the x were on the bottom, we might need to do this in a few extra steps to move the variable up to the top. But the principle is the same. We use multiplication to make division go away. But in high school math, you're much more likely to see fractions attached to the fronts of variables. In this case, we have 4/5 times x. And we know that we can get rid of multiplication by doing its opposite, which is division. There's nothing wrong with dividing both sides of this equation by 4/5. We would just need to make sure we use keep, change, flip to divide the fractions. However, I get why that's confusing. And the easier way is to use multiplication. We can multiply both sides of this equation by 5/4. The flipped version of a fraction is known as its reciprocal, and it's a very useful tool. Because we can reduce before we multiply, we see that the reciprocal lets us cancel out both parts of a fraction, leaving us with just the x. On the other side of the equation, we're just doing simple multiplication. Using the reciprocal is easier because it doesn't involve as many steps as division, and it takes up less room on your page. There are a lot of ways that we can make fractions look more complicated, especially once we start to involve variables and algebra. But the rules don't change. Multiplication of fractions will always be the easiest thing you can do. Addition and subtraction will always require common denominators. And fractions must always be reduced to their simplest form. Hopefully these explanations clarified the rules for you, but I'll end by reiterating the most important rule. Fractions are division. That simple fact takes fractions out of this special realm of weird math that you've put them in and reminds us that fractions are just numbers.